As you can observe, our lesson for today will be about composition of functions. Before we will dive in, let us first acknowledge our learning competencies. So after this session, we should be able to 1. Define what composition of functions should be. 2. Understanding the parts of the equation in the composition of functions. 3. Enumerating the steps in solving composition of functions. And lastly, applying in solving composition of functions. Let us first define what composition of functions are. Composition of functions is a function that substitutes another function. It is written in parentheses f, o, then g in close parentheses, followed by parentheses x in close parentheses equal to f entry g in close in parentheses x, then finished by an close entry. It is read as f composed with g of x. As you can observe, there are two given functions, namely f and g. In a composition of functions equations, there are two different kinds of functions. The dependent variable is the function whose x variables will be substituted, while the independent function is the function that will substitute the x variable of the dependent function. In f is the dependent variable, while g is the independent variable. In equation form, the dependent variable will always be the first to input before the independent one. Let us now enumerate in how to solve the composition of functions. So the first step is to identify the dependent and independent factor. As I have said previously discussed, we will apply that. You can observe the equation is in parentheses, which translate to the substitution of the independent function. Should always be enclosed in parentheses. Why, you might ask? For it is a needed operation in the form of distribution. This distribution can be done in two ways, through an exponent and a number. Distribution pertaining with only numbers is done by multiplying all variables of the substituted x variable, while distribution found in the exponent is applying exponential equations to all the variables in the substituted x variable. So after we substitute and distribute, we will now need to proceed to the next step, which is combining like terms, which should go in a sequence of letter variables first, number with variables next, and lastly, just numbers, and simply by combining, we have found our composition. We will now apply our steps to different equations. Take note that not all equations are solved the same way for the given of each function. It may vary in different types of algebraic functions. Let us apply what we learned with example 1. We are looking for the composition of f with g. Let f be 5x minus 3. Let g be 3 minus 2x. The dependent variable is 5, as you can observe from the written equation. That means we will substitute all the x variables found in function f. It will now be written as 5 open parenthesis 3 minus 2x close parenthesis minus 3. Again, always enclose the substituted x variable in parentheses. After that, we will distribute for you. Can observe the number 5 is the number found next to the substituted x variable. Therefore, the operation of distribution will apply. So now, the equation will turn to 15 minus 10x minus 3. Is this the final answer? No, we will still have to combine like terms. Take a look at the equation, we can see that there is only one term we can combine, that is 15 and negative 3, while negative 10x has nothing to be combined with. So we shall input that first. And as we combine 15 and minus 3 by subtracting, it is dependent to add or subtract depending on the symbol. So we now have 10x minus 12, which is now our final answer. Therefore, the composition of f with g is 10x minus 12. Okay, so let us move on to our second example. So it states to find the composition of h with g. Let h be 3x2 plus 6x minus 4. Let g be negative 3x plus 4. H is the dependent function, so it will be the function whose x variables will be substituted. But sir, there are two x variables. What do we do? Simply substitute both of them. Both substitutions are still enclosed in parentheses. So now, the substituted equation is written as 3 parentheses negative 3x plus 4 close parentheses 2 plus x parentheses negative 3x plus 4 close parentheses minus 4. Notice that in the first part of the equation, there is a number and exponent. Sir, we should only distribute 1? No class. Apply both in distribution. So now, when we finish distributing all of the exponents and numbers, we are left with 27x2 minus 72 plus 48 minus 18x plus 24 minus 4. So we combine the like terms. 27x2 is the only variable with a squared x variable. So it has not variables to combine with. Combine negative 72x plus negative 18x. Combine 48 plus 24 minus 4, which leaves us with the final answer of 27x2 minus 90x plus 68. Therefore, we can conclude that 27x2 minus 90x plus 68 is the composition of h with g. Let us proceed to the next example. So what can we observe with the given? We can observe that the independent value is in fractional form. In this equation, we are going to solve the composition of g with h. Let h be 1 slash x and g be 3x plus 5. So when we substitute the equation, it will form into 3 parentheses 1 slash x plus 5. So how will we distribute if the substituted variable is a fraction? Simple. There are two concepts to this. Observe the fraction's denominator first. If it is the same value as the number used to distribute, simply cancel out or divide the like terms. Then you are left with just the numerator. If the denominator is not the same as the number used to distribute, then distribute only to the variables in the numerator. And in cases of exponents, it applies to both numerator and denominator. That said, we can observe that 1 slash x has the denominator of an x variable. Therefore, cannot cancel everything. But we can distribute to the numerator. So, we are now left with 3 slash x plus 5. since a fraction and a whole number are not like terms that cannot be combined. So we can conclude that the composition of g with h is 3/x plus 5. What if we will reverse the roles of the independent and dependent functions? Is it still considered a composition of function? Yes, it is still considered as a composition of function. However, if you switch the functions from independent to dependent, the roles of the functions will take on the role it was switched with. Let us use our previous example. We will now find the compositions of h with g. Since we have inverted the roles, h is now the dependent variable and g the independent. That means the x variables of h are the variables we will substitute in. So it will become 1/3x plus 5. And since there are no like terms, this is now our final answer. Therefore, the composition of h with g is 1/3x plus 5. Okay, so that sums up our discussion on composition of fractions. And also, we should remember how to solve compositions, for it is an important factor in inverse functions. How come it is important? Well, you see, an inverse function is a function that reverses the x and y variables a function. But how is composition of function related to inverse functions? It is used to check if the given functions are truly inversely related to each other. So how would that apply? Let us use our last example. As you can see, we have tried to switch the roles of the dependent and the independent variables, right? That in itself is applying inverse function. However, this kind of equation is only used to check if the given equations are truly inversely related. So how can you tell if it is the inverse of a function? If and only if the composition of both functions are equal to each other. Since our previous examples, compositions are not equal to each other. Therefore, we can conclude h is not the inverse function of g.